Greetings, integrated science students. I'm outside here to bring you a demonstration of the size and scale of our solar system. In order to do that, we're going to make, basically I'm going to step out, so measure off, roughly, the distances to the various planets as a scale diagram activity, okay? For the purposes of this demonstration, the sun, that giant ball of gas that heats and lights our Earth, that 1 million Earths could fit inside of it. We're going to pretend that that sun is only the size of a golf ball, like approximately half the size of my fist, not much bigger than a golf ball. That is tiny, okay? So we're pretending that the sun is actually that small. We're going to represent that sun by this goalpost right here, where it's touching the ground, okay? So right down there, that's our sun for this activity, all right? So then we need to ask ourselves, well, if that's our sun and that's the size of the sun, how big are the planets? Well, on this scale, Jupiter would be smaller than the period on a page, and Earth would be essentially microscopic, okay? So the planets are tiny, like impossibly small at this scale. So then how far is the distance between them when they're essentially like pinpoints of size, right? So we're going to start with the inner planets and we're going to step off the distances between them. So starting with Mercury. Mercury is 1.5 steps away from the sun at this scale. So we're going to say 1.5, and we'll put in a flag on the ground right there to represent Mercury. To get to Venus, we're only going 1 step further than that. So 1 step, and we'll put in another flag already. Close, right? Not far at all. Of course, in reality, it would take quite a long time by spacecraft to get between either of those planets at our current speeds. But remember, our scale is incredibly small. So 1 more step to get to home sweet home, Earth. Okay, so that's pretty simple, right? Like Earth is only 3.5 steps away from the sun at this scale. That's quite close, actually. So if we look back, there's our Mercury, Venus, and let's see, Mercury, Venus, and Earth. Nestled cozy right up against the sun, right? But keep in mind that these planets that are quite enormous on this scale would be the size of, like, essentially microscopic. You wouldn't be able to see them. So the distances between these planets are much, much, much larger than the planets themselves. And of course the sun is back over there. Okay, onwards we go. It's quite a bit further to Mars than it is, like Mars is further away from us by a significant margin than Venus is. So 2.5 steps. 1, 2.5 steps. We are at Mars. Okay. Now for the really big one. We've got our inner planets. Let's head out to the first outer planet, Jupiter. So far we are only 6 steps away from the sun. But in order to get to Jupiter, we need to be 20 steps away from the sun. This is why they're called the outer planets, okay? They're quite far away in comparison to the inner planets. So, 14 more steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 steps. So, let's put in a flag to mark Jupiter. And then let's have a look back at the flags we already planted. There they are. Mars, Earth, Venus, and Mercury. You almost can't even tell them apart anymore. And we're not even that far away yet. And then there's the sun just past them. And here is our flag for Jupiter. Now you might wonder, how far is Saturn? Well, Saturn is even further away from Jupiter than Jupiter is from Earth. So from Mars, rather. So here we go. 16 more steps to make a total of 36 steps to get to Saturn. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here we are, nice and cozy already at Saturn. All right, I'll turn around and show you everything again in a minute, but let's get to Uranus first. Uranus, surely it can't be that far to Uranus, right? We're 36 steps away from the sun already. How far could it be to Uranus? Well, how about another 36 steps? Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 steps. Wow, that took such a long time. In reality, this would have been years, literally years of time for a spacecraft to get this far away from the sun. As you know from last week's, was it last week? I think it was last week's episode, The Giants, right? The episode that explained how they get to, how the mission, Voyager mission, right? Well, here we are, all the way out at Uranus. Gives you an idea, right? You can clearly see Saturn's flag, you can see Jupiter's flag, and you can't even tell apart the flags for the inner planets anymore, because they are so close together compared to how far away we are, okay? We are at this point hours, light hours away. It would take hours for a radio signal to get to a spacecraft this far away. All right, let's go to Neptune. How far is Neptune from Uranus? Well, Neptune is even further away from Uranus than Uranus is from Saturn. So here we go. 41 more steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Here we are at Neptune. Now let's just stop and take a look back. There is the line of planets. Now, I will point out that the planets are almost never aligned this way, right? It's extremely rare that all of the planets are on the same side of the sun in a straight line. This basically never happens. They're usually scattered around in their various orbits all over the place around their sun, but extremely rarely they would all be lined up like this. We're just pretending like they are when we're using average distances to do this. But you can see Neptune is way out here in comparison to the other planets. We are in the outer solar system here. Now, I don't have a flag for Pluto, but I'm going to go ahead and pace off Pluto anyway. This being the furthest, not actually quite the furthest body that's been visited by a spacecraft, because New Horizons did actually do a flyby of a different Kuiper Belt object way out there. But anyway, if we were going to go to Pluto, we'd need 22 more steps to get to Pluto's average distance from Neptune. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And here we have it. This is the outer edge of what used to be considered the solar system, all the way out to the first of the Kuiper Belt, the largest of the Kuiper Belt objects, Pluto. We look back and we can see the flags that represent the planets, the 8 planets of our solar system, viewed from Pluto. There they are. Incredibly huge distances. And remember, each of those flags represents an object that at this scale is no larger than the period on a page, and probably for most of them, not even visible to the naked eye. So that is crazy. The solar system is incredibly enormous and way bigger than the planets or even the sun. Okay? Keep in mind the sun way back over there is the size of a golf ball. And that concludes this demonstration.